Greetings, scientists. My name is Haley, and I'm with the Education Department here at the Discovery Center of Idaho. I'm also here with Tinker the dinosaur, who is 66 million years old. And I think she looks pretty good. She looks pretty good. Welcome to our virtual Dino Camp. Now, I chose a lesson from the day where our theme was, what is a dinosaur? And I thought that the Mesozoic Scale was a great place to start because I find it extremely fascinating how enormous some of these creatures are, right? I mean, your learning objective today is that we are going to compare and contrast both prehistoric animals and their counterparts, as well as being able to understand how Earth's conditions can influence their life. How big really was Tinker? Can you imagine any modern day animals that might be bigger? Or any other prehistoric animals? It really is something you have to grasp. I mean, for this to be around roaming in our yard 66 million years ago is hard to comprehend sometimes when we're used to cute little dogs running around. Now, our activity today is going to visually show you what the difference in length between a prehistoric animal and a modern animal. Now, I'm pointing to the ground because I have various lengths of cords lying, and you'll see that in a minute. And each is measured out to the length of these animals. If you would like to participate at home, you'll need to grab at least 50 feet worth of some kind of rope or string. It could either be paracord or hemp or some string like bracelet string or maybe some jump rope, who knows, get creative. Animals that we're going to compare and contrast are going to be the largest T-Rex and Tinker. Now, the largest T-Rex is actually Sue, which we at the Discovery Center of Idaho had here in our very own galleries not too long ago. Now, this would be the time to go ahead and grab your rope or string and measure it out if you'd like to do these with me. Sue is 42 feet long. Pretty big. Now, Tinker is only 30. I say only, but that's still huge. All right, we're gonna go ahead and grab our paracord and visually see the differences between these creatures, okay? Pay attention to this white cord. You see where my foot is touching? All right, now check out how long this is. Now this is, to remind you, Sue, and she was 42 feet long. Oh my gosh, I'm still going. And it's under the table. Man, and just to compare, this is Tinker. I just walked the full length of this gallery. As for Tinker's size, if you can just see the end of this white cord here, remember from Sue, and then just peek. See the beginning of that green cord? That's Tinker. So it goes all the way back to the beginning of the gallery where I started with the white cord, and it stops about there. And you can see Tinker's tail is what makes it just that little bit longer than the display. Let's compare our snakes. Now, the largest snake is 42 feet long, just like Sue. So if you can remember how long that white cord was all the way down the gallery, that's how long this prehistoric snake was. And the actual name of it is a titanoboa. If you check out this picture, you can see how large it is. I mean, that could eat a modern day alligator for sure. Modern python that you've probably seen at the zoo or maybe at a reptile birthday party or something or other, that is 30 feet long, just like Tinker's length. So if you remember the green cord on the ground, it's just a little bit shorter than that giant snake. So snakes are just generally still terrifying, so that's good to know. Let's compare our insects. Now, the largest insect had a wingspan of 2 feet long, which makes it look much bigger than maybe the body is, but the wings extended outwards. So that's how long I cut my rope. The modern dragonfly is only 7.6 inches. Now, if you want to go ahead and measure that one out, go ahead. I'm going to grab my rope because they're nice and short. Now, this white one is how large a prehistoric insect was, and it looked like a dragonfly. They're very similar. It's pretty, right? It's probably the length of my arm. That's still really big. It's a pretty big bug. This is how big they think it was. If to compare to a human, it's a meganura. My pronunciation needs some work. Meganura. And as compared to the modern dragonfly, well, it's a little itty bitty, right? That's how big our modern dragonflies are. You probably see them out and about, maybe in your yard or camping. If you need a visual, I got one for you, right? We know what a dragonfly looks like. And last but not least, my personal favorite, the sloths. Now, a prehistoric sloth is 18 feet tall. All right, that's pretty big. And the modern sloth, the ones you see at zoos or maybe on TV, they are only 3 feet. So, grab your cord, measure it out, do what you need to do if you'd like to participate, or follow me. We've got the start of the rope right there. You see the blue tape? And I'm just gonna like walk backwards. Hopefully I don't trip on anything. The light's kind of hiding it. Sorry. And boom, right there. So it's, you know, the other direction of the gallery. That doesn't really help you with length, but they're as tall as trees. These giant sloths were roaming around like giraffes do in safari. They were towering creatures. And the sloths that we see today, now I've got the rope, I'll hold it up to me. It's as long as it goes to my neck, all the way to like where my pants meet. That's about the size of a modern sloth. It could like hang on my belly and be my little friend. In comparison, I'll lay this down on the ground and kind of show you. The light's really bad. Oh, the light's still really bad. See it right there? You see the white and huge, long prehistoric sloth and the miniature sloth. Can't forget to show you pictures. So here's the prehistoric sloth. It's a Megatherium. You can see that like the mountains, I mean these things were big. They were like picking stuff from trees, you know? And here is your modern sloth. He's so cute. Look at him. The big question is, how did these animals differentiate so much in size? Scientists have come up with a few different hypotheses that really play with a few different ideas. Now the first one I'm going to add here is high oxygen levels. High oxygen levels has impact on creatures because the best analogy I can give you is like food. So if you put more food on your plate, you are generally going to get bigger. Oxygen plays the same role in the environment. If you add more oxygen, plants, for example, will become more lush and they will grow bigger and stronger. And you can imagine it's the same thing with animals, especially if there aren't any humans roaming around. There's no buildings in the way, so it even enables these things to have no limit. They can grow and evolve however they would like to. Another reason how Earth's conditions influence these animals is the availability of space. And I kind of brought that up with saying, you know, how humans weren't around, we didn't have buildings and homes, but there was tons of space. We weren't taking it all yet. So these animals probably had the freedom to grow bigger and eat more and have a little more space, reproduce, carry on that species' legacy. Another one is the respond to environment. Messy writing. Respond to the environment. Now, the reason that is on this list is because dinosaurs needed to survive, and there were lots of species, lots of competition, and it was survival of the fittest. If they shifted in size, got larger, it was probably to protect themselves, to respond to the environment. Again, survival of the fittest, and it's so that modern pythons and dragonflies and sloths can exist is because these species adapted to what was around them. And here we are today. I hope you had fun today. We love learning at the Discovery Center of Idaho, and we hope you do too. Remember to share your curiosity with us and the community. Tag us, hashtag us, all of the above. And remember this one. Our minds are our greatest weapons. Continue to nurture them, continue to learn. We hope to see